Okay, I'll be starting with the session now. So, hello everyone, dear authors and invited guests. Welcome to Technical Session 12D. I am Dimahi Patel, and this session will be moderated by me. On behalf of Global Knowledge Research Foundation and GR Scholastic LLP, it is my great pleasure to welcome you to the 10th International Congress on Information and Communication Technology, London, United Kingdom. The 10th edition of the conference is being organized in a hybrid mode. The physical event was held on 18th February in London, and the virtual event is being held through Zoom from 19 to 21st February 2025. I hope you will enjoy the knowledgeable and interactive sessions through the day. In this session, we have 6 presentations. Each presenter will be given 12 minutes for the presentations and 3 minutes for the question and answers. On 10 minutes, I will raise a gentle reminder. There is another request to all the participants that you all stay connected with us till the closing remarks. If you have any query or update, please write it to me in the chat box. Now, before we start with the presentations, I would like to introduce you all to the chair of this session. We have with us Professor Jihan Mohammad Ahmed Al-Garadi. Professor Jihan is an assistant professor at Tez University, Yemen, specializing in computational linguistics, syntax, data mining, and educational technology. Through her academic contributions, she advances knowledge in computational models for language and the integration of technology in education. I welcome you, ma'am, to this session, and I request you to share a few words you may have to the presenters today. Jihan, ma'am?
Yes, am I audible?
Yes, ma'am.
Yes, thank you very much for your kind words. Yes, my name is Dr. Jihan Al-Jaradi, and my specialize is computation linguistics, and I'm very happy to be one of the session chairs in this. And I think and expect to be informative and insightful session.
Thank you so much, ma'am. We also have with us Dr. Nidhi Tiwari as our session chair. Dr. Nidhi Tiwari is an associate professor and research and development head in the Electronics and Communication Engineering Department at Sage University, Indore, India. With 13 years of experience, her expertise spans VLSI design, intrusion detection and prevention, computer networks, network security, cybersecurity, data science, artificial intelligence, and machine learning. Dr. Tiwari is dedicated to advancing research and education in these cutting edge fields. I welcome you, ma'am, to this session, and I request you to share a few words with everyone today.
Thank you, ma'am. And as the session chair, I am honored to be part of this esteemed gathering of researchers and professionals. This conference serves as a vital platform for exchanging ideas, discussing research, and fostering collaborations that can drive innovations in our field. The session ahead promises to be both insightful and obviously inspiring, with distinguished speakers who will share their expertise and latest findings. So before we begin, I would like to extend my gratitude to the organizers, sponsors, and everyone involved in making this conference as a success. I encourage everyone to participate actively, ask questions, share thoughts, and to take full advantage of this opportunity to learn from one another. With that, let us begin. Thank you, Dimahi also, and let us have a great session.
Thank you so much, ma'am. Now we will be beginning with the presentations. Coming first up is Libero Negro. I request you, sir, to present your study in clustering by an evolutionary random swap algorithm.
Sorry. I will talk about a project, a research project, which concern the development of an extension of a clustering algorithm, which is a random swap. The goal is to improve random swap, which is a well-known good algorithm in general, to improve it further with concept from genetic evolutionary technique. Now, I will try to give you also evidence about its behavior when applied to several kinds of data sets. And I would remind you that we often are faced with the K-means. K-means, which is a well-known algorithm used uh, essentially because it is simple to understand and also efficient. But K-means suffers of some limitations because it strongly depends on the initialization of centroids, and also it easily can block on a local suboptimal solution. Now, uh, random swap tries to give over this limitation because random swap basically at each iteration swaps a centroid of a current solution with a point of the data set. In this way, random swap is able to configure centroid which moves all over in the data set. So a global search, it is introduced, contrary to the k-means, which instead is a refinement technique, and centroid in k-means cannot go over all the data set. Now, essentially, what we do with the random swap is to, at each iteration swap, we select randomly point in the data set and replace a randomly chosen centroid in the vector, current vector of centroid. We evaluate the new solution with a few iteration of k-means, and then if the cost, which is normally the sum of squared error cost, if the cost is improved, we take the new solution as the current one for the next iteration. And what is interesting to recall is that random swap prove very interesting in practice because it is able to approach a solution close to the optimal solution. Now, when using a k-means or random swap, standard random swap, we need to use some implemented, some seeding method to initialize centroids. And this is a list of, we have implemented the seeding methods. And also on the right, you see some number of measuring, clustering measures, indexes, with which we try to assess the goodness of a solution. Now, in this work, we basically have developed a different, careful initialization method, which is, say, the refine piecewise nearest neighbors. Basically, the dataset is split in a number of segments, which are filled randomically from the point of a data set. Then each segment is separately clustered with k-means. And then after this, we achieve the number of segments per k, which is the number of cluster, solutions which are available. Then we reduce such a number of clusters to k through piecewise nearest neighbors, which means that at each time we select the pile of solution of cluster whose merging would increase the cost SSE by the minimum value. And what is interesting that we can predict in an easy way both what will be the increment in the cost and also what will be the centroid of the merged cluster in an easy way analytically as is shown in this slide. Now, what we do in the extension of random swap basically is to build initially a population of solution. So we apply repeatedly J times refine PNN. We use it to populate this set of initial solution. J must be chosen according to the feature of the data set which we have to handle. After the population has been created, we recombine the solution, the centroid of the population. And what is new in our approach is that swaps are accomplished between centroids in current solution and the point chosen in the population. And all of this practically is confirmed by experimentations, by experiments, allows evolutionary random swap, which is the name of our tool, to behave better in the sense that we have noted that we can achieve a good, very good solution close to the optimal one in few iteration, which means goodness, and also we save time. Now, to give you what we have done with our tool, these are some data sets we have chosen to check the features of the evolutionary random swap. This is a regular data set because it is composed of spherical clusters, but it is not trivial because it has 100,000 points in bidimensional space, but also it has 100 clusters. And what you can see from this table, we achieve, as witnessed by the minimal value of the cluster index, which is expected to be 0 for the solution to be a correct solution, because a clustering solution with the minimal 0 value of cluster index is structurally correct. And this is a data set regular, but you see that when we use a standard random swap, we achieve a minimum 0, okay, in 84 second runtime. And you see that we achieve also the minimal 0 value of centroid index, but in this case, in 3 seconds, after we have built the population, which consume other 5 seconds for building the population. Okay, and you also see that in our tool, with our tool, the average value of the centroid index keeps to be 0. But when using random swap, standard random swap, the average value is 33. Ora, to understand what is the average value, you must think that the centroid index indicate how many centroid we make a mistake in predicting its value. So on the average, 33 centroid are wrongly predicted. 33 over 100 are improperly detected by standard. But in our case, on the average, we make 0 mistake. Now, this is another data set which has a particular cluster, which it is not regular in this case. It is a well-known data set which is handled in a very good way by density peaks based clustering algorithm. We have solved it by using our tool, and also in this case we achieve a cluster index 0. In this case we optimize, instead of the sum of squared error, we optimize, which means we maximize the silhouette index, which gives us an indication of a well-formed cluster. Well-formed means a compact internally cluster, and also well-separated cluster one to another. And these are 2 other very, very difficult in the literature known data sets, which are made up of a high number of points, and also a high number of clusters centroid. But what is most important is the internal structure of clusters, which is very difficult to handle both in BIRC tree and also in the worms 2D, 2D, 2-dimensional. Now, in this case, we used the 80 solution in the population, and it emerged that one in 11,
Excuse me, sir.
Yes?
I'm sorry for interrupting you, but this is a gentle reminder that you have crossed your
I
10-minute
must,
mark.
okay.
Yes,
Thank you
yes.
for your attention.
Okay.
No, I think it's very strange to allow 2 minutes to talk about a research project, but I understand and respect the timing. Okay, if there
No,
are
sir, thank you very
questions, I
much.
am
Your presentation
here.
was
Thank
very
you,
nice.
thank you.
Ma'am, do you have any questions for him? Jihan, ma'am?
Yes, ma'am. Thank you very much, Prof. Libero, for your insightful presentation. I think your research is well structured and clearly articulated by you, and I think it would provide contribution to the field. One area that could enhance your work further, I think if you could provide deeper comparison with the related work. Thank you, sir.
Sorry, what is your question? Sorry?
I think it's bit. I mean, it will be a good contribution of your work if you can provide a deeper comparison with the related work in the field.
Comparison. Okay. Comparison. Yes.
Yes.
Now, here I was in the position to give you some information about this, in the sense that the comparison in this case is with trivially with the standard random swap. And with the standard random swap, for example, when we consider big tree, in 11 value for the centroid index emerged with a time of 5,100 seconds. We achieved the same value because this is a very difficult, hard data set in about 100 seconds. You see that the comparison indicates that it is a promising our tool because it achieves in the literature it is reported no best value rather of this 11, in the sense that 11 over 100 are the error we commit in clustering this kind of data set. Similarly, in the case of worms today, we make an error of 7 partition over 35, and this is the best value in the literature. In the literature, it was also greater than 7, and we achieve this value with respect to standard random swap in very, very few time. So this is an indication about a comparison of the performance of our tool with the similar competing tool, which are available in the literature. Thank you.
Thank you, sir. Great job.
Okay.
Dr. Nidhi, do you have any questions for him?
Not exactly questions. Only one suggestion is there. Libro sir, your research contribution is very useful, and same suggestion from my side also. Please add previous references with your research. Just add previous research or research paper and references, citations, add in your research.
If I have understood the question, this is just one direction of our current
Yes.
research, because also we also follow the idea of density peaks based clustering.
Yes.
And with density peaks based clustering, we achieve a similar result about the evolutionary random swap. So this is just one way to making good clustering from our point of view with respect to similar tools which are available publicly. Okay?
Okay, great job.
Okay, thank you so much, sir, for your presentation. Now, next, I would like to call Amir N. Sir to present their study on example guided prompt tuning for sentiment analysis of code switched Hindi and Dravidian languages on Llama.
Yes, I am here.
Yes, sir.
Okay. I can share now. Okay. Awesome. Can you see my screen?
Yes, sir, your screen is visible to us.
Okay. Good morning, everyone. My name is Amir Ince, and today I'll be presenting our research on our example guided prompt tuning for sentiment analysis of code switch Hindi and Dravidian languages on Llama. So here are the authors of the paper. Oh, my screen's frozen. Okay, very good. The authors are myself, Howard Priolu, and Dr. Saurav K. Arya. Before we dive in, let us look at some key terms. Code switching. Code switching is alternating between two or more languages within a conversation or sentence. Sentiment analysis is identifying and categorizing opinions expressed in text as positive, negative, or neutral. Prompt tuning, this is a technique where prompts fed to large language models are optimized to guide these models in performing specific tasks without fine-tuning the model itself. Zero-shot prompting is a prompting technique where the model is asked to perform a task without any examples in the prompt. We simply give the instruction to the model and expect it to perform the task. Then finally, few-shot prompting is a method where the model is provided with a smaller number of examples, typically 3 to 5, to guide its understanding of the task. The expectation is that the model better understands the task it has to perform, giving some examples and their labels. So, nearly half of the world is bilingual, and yes, large language models have made significant progress in multilingual understanding, but still, they struggle with understanding code switch text. Now, why does this matter? Well, with the rise of social media, there has been a drastic increase in the number of code switch texts being generated. And this presents a unique linguistic challenge for sentiment analysis, particularly for code switch text. Our objective is to evaluate the model's performance without fine-tuning, and then also to see if we can enhance the performance of these models by using various prompting techniques. Let's dive into our datasets. I must note that code switching sentiment analysis datasets are scarce due to manual annotation demands. These datasets from social media and published works represents real challenges in this niche and are currently the only standard resources. The datasets used in this study consist of approximately 74,000 examples across 5 language pairs, those pairs being Hindi English, Tamil English, Malayalam English, Telugu English, and Spanish English. We must note that we excluded the Spanish English dataset because the test set did not include the goal labels, which prevented us from conducting a thorough error analysis as we were able to do with other datasets. For this study, we focused solely on Llama language models. We see here a chronological overview of the Llama model family's evolution, showcasing key metrics for each version from the original Llama to Llama 3.2. The key feature we want to note is, in addition to the parameters, is that the improvements made in multilingual abilities across successive iterations. Now, due to their open weight, accessibility, and inexpensive compute requirements, we've chosen all models with a parameter size less than 8 billion for our analysis. So based on this table, we used 5 models in all, 1 from each iteration of Llama. So let's look at our prompting techniques. Our first approach was using a zero-shot approach where we just fed a naive prompt to the models and used the same base prompt for all of the data sets to classify the sentiment of the text as positive, negative, or neutral. Our second approach was a few-shot approach where we enhanced the prompt by adding 5 examples to each one. For every language pair dataset, we created a tailored prompt selecting examples from the zero-shot stage where the models had previously failed to classify that particular example. So this ensures that the model received targeted guidance for improved performance. Our third method was a prompt optimization framework. This is an open source iterative system that automatically optimizes a prompt given a base prompt and instructions describing the task we want to achieve. This method is a little bit complex. It uses a mixture of large language models to refine the prompt, but the key feature is that it generates synthetic data in English, which it then uses to evaluate and refine the prompt. Our fourth method was a modification of the prompt optimization framework. So remember, it generates English-based synthetic examples. So instead of having it generate those examples, we actually fed it real examples from the training set instead of using that synthetic data. And one prompt was created for each language pair. Our fifth and final technique was a few-shot prompting with metaprompt. This method combines method 2 and 3, incorporating 5 initial examples into the base prompt and then using the prompt optimization framework to refine the prompts. So synthetic examples, synthetic English-based examples were used to refine the prompt for this method. Let's look at some results. So here we have a table detailing the average performance of each llama model for each prompting techniques using the macro average weighted F1 score. Clearly, we can see Llama 3.1, the 8 billion parameter model, it performs the best and most consistently across the different prompting techniques. And this shows how robust this particular model is and highlights the improvement in the model architecture that helped with sentiment classification across various multilingual datasets. If we compare the Llama 2 7B, Llama 3 8B, and Llama 3.1 8B, we can clearly see how each successive model improves on the last. And evidently from these results, we can see that prompt optimization plays a major role in improving zero-shot performance. And it shows that if we carefully craft our prompts, it can be very useful in boosting model understanding and classification accuracy. And this is very important because with the correct prompts or refined prompts, smaller models can actually compete with larger ones in complex tasks like sentiment analysis. Now, our modification in method 4, switching from synthetic to real dataset examples, improved performance for most models. However, with method 5, in some cases, it actually decreased performance, likely due to overfitting and other challenges. Here we have a table detailing the average failure rate of each Llama model for each prompting technique. From the previous table, we saw Llama 3.1, 8 billion performing very well, but now we see here it is kind of vulnerable to failure in certain techniques. The Llama 3, 8 billion model maintains consistently low failure rates, excelling in zero-shot and few-shot methods. And we see that smaller models tend to struggle with higher failure rates, especially as the prompting technique becomes more complex. Few-shot method 2 and prompt optimization with dataset examples method 4 offer the best balance of performance and low failure rate across models. Our results show that synthetic data used in prompt optimization tends to increase failure rate and decrease performance. This negative effect is amplified when the model has to generate examples in the original language of the text. Overall, these findings suggest that real-world examples and language-specific data in prompt optimization may lead to more reliable results for sentiment analysis in the multilingual space. Although all these techniques are pretty useful, they still fall short of the current state of the art for these task dataset peers. And these results ultimately highlight that without fine-tuning, large language models remain unlikely to understand sentiments in code switch text. Here we have a plot that illustrates the average model performance. The average performance per model across language pair datasets ordered by parameter size. A notable trend is that there's a fluctuation for Llama 3.23b and Llama 2.7b, where the performance varied significantly depending on the language pair dataset. Despite these variations, the overall trend represented by the black line, the black dotted line, indicates that models with larger parameter sizes, and the newer the model, it generally tends to perform better on average. Here we have a line plot demonstrating the average failure rate per model across datasets ordered by parameter size. So larger models, such as those from the Llama 2 family and Llama 3 family, generally exhibit reduced failure rates, reflecting their improved ability to handle diverse and complex tasks. However, there was an unexpected spike in failure rate for a Llama 3.1 to 8 billion model. Despite having a high parameter count, this anomaly suggests that while the model excels in some areas, it may be less effective in handling certain multilingual tasks, potentially due to overfitting or even suboptimal fine-tuning for languages beyond those it was primarily trained on. So here we have just a set of limitations of the study. First of all, we didn't fine-tune or augment models with additional context, limiting their ability to handle linguistic nuances in code switching. Additionally, all prompts for method 3 were generated in English due to the method prompt framework that we used. We also had some model size and computational constraints, which kind of restricted the exploration of how larger parameter size would affect the impact of these models to accurately classify the sentiment. We do expect that performance would increase as the parameter size increase, but we focus on Llama models due to accessibility, their known pre-training data, and just efficiency. And this overall excluded other potentially stronger models or solutions available. AI models used in this context may reinforce sociolinguistic biases in code switch datasets. And also, generalizing these models to other language pairs or social settings could introduce inaccuracies or biases requiring ethical considerations. We do anticipate refining this work in further iterations to address some of these iterations. And with that being said, I've reached the end of my presentation. Thank you for listening. Are there any questions?
Jihan ma'am, do you have any questions for him?
Let me say that thank you, Prof. Amir. Actually, your presentation is well organized and insightful. And I think this is one of the novel studies that can deal with sentiment and code switching between, two different languages. See, actually, I have two questions, but through your presentation, when you come to the limitation point, you answer my questions, one that related to the why you use only Llama model, and the second one is regarding the bias. Actually now I don't have a question, but I have an inquiry. Whether do you think this your approach can be generalized to other code switched languages rather than Hindi or Dravidian languages? Thank
Yeah,
you.
I do believe, sorry. Yes, I do believe it can be generalized to other languages. However, the main challenge is there seems to be a scarcity of well-annotated data sets. If we can get those data sets, the framework that we develop to run these experiments is very modular. So literally you just supply the data set and the initial prompt, then the framework runs that we created runs everything else and generates all of the results, metrics, and everything. So it definitely can be scaled up and generalized to other data sets.
Okay, thank you. Great job.
Welcome. Thank you, Professor G.
Dr. Nidhi, do you have any questions for him?
Can I ask about two curiosity
Thank you,
questions?
Professor Amir. Your model is good. And so I just want to know about GPT and PALM. GPT or PALM. How is it different from this?
Okay, you said you want to know how GPT and Claude are different from Llama?
GPT or PALM? This is already going on GPT or PALM, and I think your model is different from this, right?
Yes, we did use
Yes,
instead of
yes.
GPT or those other models, we use Llama. which is from
Yeah, you are using
Facebook.
Llama. Yeah.
Yes.
So I just want to know basic key difference between these two.
So off the top of my head, I'm not too sure of the key differences between the GPT models and Llama. Uh,
Yeah.
there are the specification sheets available online. It's
Mhm.
the differences vary a
Hmm.
lot from model to model, especially with
Hmm.
parameter sets. It's kind
Hmm.
of hard to keep all of it like within my head, but I would definitely look into it to see for comparison's sake.
Yeah. Yeah. Okay. Thank you.
Sorry,
Yep, sorry I couldn't
can
assist
I ask
any further.
you, to curiosity, uh, since you are doing clustering of course in your work because you have data sets and also some measures now about good clustering. My question is, what kind of distance metric you use? For example, in our work, since we consider the data set with the numerical features, numerical coordinates, we use Euclidean distance. But in your work, what kind of distance you use between, I suspect, words of the language you are interested to cluster? Thank you.
Yeah, that's a good question. So we didn't really do any fine tuning or training with the models, or even any sentiment analysis stuff. These models we have are pre-trained, so we essentially just gave them a prompt and then compare the output of the model with the golden labels to see how well they perform. So we didn't do any clustering, just measuring of performance. Does that answer the question?
Yes.
Okay, thank you so much, Amir sir.
Thank you.
Now, next up, I would like to call Hector Rafael Morano Okuno sir for presenting their study on exploring prompt engineering for generating G code to program CNC milling machines.
Okay, I'm going to share my presentation.
Yes, sir.
Okay, so hello everyone. I'm Hector Morano. I work for Tecnológico de Monterrey in Mexico. The title of this presentation is Exploring Prompt Engineering for Generating G Code to Program CNC Milling Machines. So this is the agenda I'm going to follow. First, I will mention the objectives of this work. Then I will describe the methodology that we use. And finally, I will share the conclusions and future work. So the objectives of this work were to verify if an LLM can generate G code for machining parts on CNC milling machines that work with a specific controller. The second one was to investigate which manufacturing operations an LLM can use. And finally, to determine the possible failures that CNC programs generate by an LLM can have. Now I will describe the methodology and its main components. Let's start with the research context. So the LLM we used was Copilot. The computers on which the interactions with the LLM were tested were laptops with an Intel Core i7 processor at 2.5 gigahertz and 32 gigabytes of RAM. The CNC milling machine used to test the G code was a BF2 machine with a hash controller, a 22 carousel, and a max spindle speed of 8,100. So the methodology consisted of a sequence of steps to cover the research objectives. Figure 1 shows the different stages on the methodology used. The methodology was divided into steps. The first consisted of finding out what the LLM knew about CNC programming. It is essential to share the prompts with the answers, since the reader can observe the information asked for by the LLM and the answer it gives. With the above, it is possible to analyze the concept the LLM handles, the commands, and how the G codes are programmed. So the second step was identifying the terminology the LLM recognizes for CNC machining. So let's go to the first stage, find out when the LLM knew about CNC programming. Initially, to introduce the LLM to the context of CNC programming, it was asked about its version. Through prompt engineering, we question if it could generate CNC code for machining. We can see in figure 2 that the first prompt used, as well as the response from the LLM. Figure 3 shows the second prompt used to determine if the LLM could generate CNC code for machining. Only the generated program is included. As can be seen, the LLM identified the hash controller and showed an example of the command it could use. So subsequently, with a third prompt in figure 4, the LLM was asked to make a program to machine a rectangular 80 millimeters by 60 millimeters using an involved Miller coder. With a fourth prompt, the LLM was asked to make the necessary modification to generate the program correctly. It was asked to add decimal points in X, Y, Z, and F variables without including the zeros that are not necessary at the end of the variables. And the program names will be 012345 instead of 02 2000. This is shown in figure 5. Finally, using the delivery G code, the program was simulated in the C milling machine interface without errors. The result is shown in figure 6, which displays the rectangular contour. Then the second stage aimed to investigate the variables the LLM requires to generate a G code, calculate the cutting parameters, and identify the manufacturing operation it handles. With a fifth prompt inspected these variables, figure 7 showed this prompt with its simplified response. The sixth prompt shown in figure 8 was used to investigate the information necessary for the LLM to calculate the cutting parameters of CNC machining, the material to be machined, the specification of the tool to be used, the capacities of the CNC milling machine, the surface finish, the type of cutting fluid, and the manufacturing operations are also required. So now we would like to share some recommendations for using prompt engineering to generate CNC code. First, we have to investigate the LLM knowledge of the CNC processor to be used, whether it be terminology, operations, cutting parameters, and structure of the CNC program. Then, if a variable of a parameter is not entirely defined, we have to request an image or equation of it. Then we have to request the generation of a CNC program with the required parameters to determine if it is correctly generate the CNC program. We have to simulate the generated example program and make the necessary modifications to show it and do the necessary modifications. Then we have to ask the CNC program required to machine a part, simulate the generated CNC program, and machine it just to test the program. The prompts in this work can be used by user to guide the LLM in generating G code and employing different machining operations. Now, here we have the conclusions. Recording the prompts is necessary as it helps users understand how the LLM understand and process the instructions. On the other hand, whenever users write a prompt and indicate whether they need G code generated or in some format, they train the LLM. The LLM can help users create G code to machine parts on CNC milling machines. However, the user needs to have basic knowledge of CNC programming to make the necessary corrections to the generated programs. The more manufacturing operations and the greater the complexity of the machining, the greater the number of modifications the users must make the CNC program. So creating G code using an LLM takes longer than a CAM software since users must only define the manufacturing operations, tools, and cutting parameters through user-friendly menus. The disadvantages of an LLM is that it does not yet fully interpret part drawings, which make it challenging to write significant text to describe the geometry. So for future work, we distinguish the following task. It is suggested that we explore the possibility of interpreting drawing using the LLM to specify the geometry to be machined, since this would reduce the prompt instructions. On the other hand, it is recommended that an LLM be evaluated for generating G code to machine parts in 3 dimensions and for manufacturing parts on other CNC machines such as CNC lathe. And finally, to be more efficient and reduce the time for prompt creation, it would be worth studying the possibility of developing GTPs oriented to generating G code for machine parts. This would automate the process of specifying the manufacturing operations and their parameters. So this is all. Thank you for your attention.
Jihan ma'am, do you have any questions for him?
Yes, thank you for your effort put on this work, Professor. Actually, I have an inquiry. Why you choose only this type of LMS? Why
Okay,
not?
because
Yeah.
yes, because this was the first work on this topic, so we needed to investigate how the LLM could respond to the prompt engineering to generate G code. That's why we started with single prompts, and then with the information that the LLM provides us, we started to plan some parts to be machining. So that's why they are really basic geometries to start with this research.
Nidhi ma'am, do you have any questions for him?
Hello, Professor Moreno. Your presentation is very nice and your work is good. The way you presented the information was insightful and compelling. And have you done any research or literature review on your work? Have you compared with others?
Yes, but there are some works, but in other areas, not just in generate G code with this technique with using prompt engineering. They use other kind of AI, like for
Okay.
example, neural networks recognizing some images, but not with prompt engineering.
Okay. Okay. So you have done comparison on images, right?
Yes, other works
Okay.
use
Other.
that techniques.
Okay. Okay. Thank you.
You're welcome. Very welcome.
If any of the other author have any question for Morano sir, please ask him right now. All right. Thank you so much, sir.
You are very welcome.
Now, next, I would like to call Hana Mohsin Ahmed ma'am to present her research on fuzzy deep learning feature-based classification using transmission casing data.
Our paper is entitled with fuzzy deep learning feature-based to classify transmission causing data. Plan of presentation. This work, main contributions, proposal methodology, experimental results, main conclusion, finally, future work. This work, our main problem is how to ensure the safety and reliability of transmission system, especially for the transmission causing data. Transmission causing data can be classified to learn the existence of fluid and monitor the conditions and also conduct prevent the maintenance. The main solution can goes with our proposal, which is fuzzy logic deep learning model to classify feature vector data of transmission causing data in specific. Our main contributions is goes in three directions. First one is to present new fuzzy system that relies on two techniques, fuzzy logic, deep learning. The second direction is to apply this model to classify transmission causing data. Finally, is to raise the evaluation of classification the transmission causing data. The proposal methodology goes in three stages. First stage is to apply a pre-processing for the input data set. Then apply fuzzification using fuzzy logic, triangular fuzzy logic. Finally, apply classification with the deep learning to classify transmission causing data. We conduct two experimental results. The first one for the conventional deep learning model, and we present here the training and testing curve, also the accuracy rate and error, and we found it that when we apply our result, when we apply our proposal for the transmission causing data, we found the accuracy rate goes to 100%. Also, we found the error goes to 0. We can conclude mainly that our proposal model can raise the performance, and also we have some limitation or future work that goes with how to use or how to choose the membership function instead of using the triangular fuzzy set. Thank you for your attention. Any question?
Jihan ma'am, do you have any questions for her?
Yes, actually, Prof. Hanan said that she do a comparison between her proposed model and the deep learning model. Can you tell us, Prof. Hanan, which deep learning model you use?
Okay, I'll present this part using my paper to show you the model which I used. The model which is I can show you the stage of the model. The input of this model is about 22 feature with the activation function, a fully connected layer with 50 fully connected layer, followed by batch normalization, which about 50 also. Then also fully connected layer, softmax, and dropout class as a final layer. This is the deep learning model which I used.
Okay, thank you.
Thank you.
Nidhi ma'am, do you have any questions for her?
No, ma'am. Professor Dr. Hannah, great job, great presentation. Thank you.
Thank you. Thank you very much, ma'am.
Thank you so much, Hannah ma'am.
Thank you. Thank you very much.
Now, next, I would like to ask Titi Adriani to present her research on integration of artificial intelligence into battery energy storage system for diagnosis, a review.
Good morning, everyone. My name is Siti Andriani. I am a PhD student in Department of Optical Engineering at the University of Indonesia. Today, I will be presenting a review of an integration of artificial intelligence into battery energy storage system for diagnosis. A total of 79% of global greenhouse gas emission are attributable to the energy industry, transport, and building sectors. In light of this circumstance, the energy industry is currently undergoing substantial transformation, demonstrated by the shift of renewable energy sources and a decrease in the need for fossil fuels. Energy storage system plays pivotal roles in integrating and balancing weather-dependent and intermittent renewable energy sources, thereby facilitating the decarbonization of the energy sector. However, due to the inherent complexity of the electrochemical reaction mechanism involved in lithium-ion batteries, there is an inherent risk of danger and potential unreliability in their operation. This figure illustrates that a minimum of 81 incidents of lithium-ion battery failures occur during the period spanning 2011-2023. So this study aims to explore how artificial intelligence can enhance fault diagnosis in BESS to improve efficiency and reliability. A fault in a BESS is an abnormal condition that occur potentially disrupting this normal operation. In BESS, various types of fault can occur. Each fault can affecting system performance and safety differently. For instance, internal short circuit occurs due to insulating failure or mechanical damage, which can potentially lead to overheating and fire hazard. Overcharging triggers hazardous chemical reaction and significantly accelerates battery degradation. Overheating results from high current or cooling system failure, thereby increasing the risk of thermal runaway. External short circuit happen when an unintended external connection is fault, which rapidly accelerated battery degradation. Overdischarge occurred when extensive energy depletion takes place, ultimately reducing battery lifespan, and so on. methodology, specifically in the context of integrating AI into base fault diagnosis. This research was conducted in accordance with the PRISMA statement. Relevant studies were collected from digital database such as IEEE Explore, Scopus, and Science Direct. And then inclusion and exclusion criteria were applied to ensure that only relevant research papers were selected for analysis. This figure illustrates the procedure and this output. Of the end of relevant output, 28 were deemed relevant and satisfies the qualifying criteria, so earning their inclusion in the final compilation of papers. In battery energy storage system, various methodologies have been employed for diagnosing fault in battery system. These approaches can be categorized as knowledge-based fault diagnosis, model-based fault diagnosis, and data-driven fault diagnosis. Knowledge-based fault diagnosis relies on expert knowledge, predefined rules, and experiences-based method to identify and analyze fault in base. While this approach does not require complex mathematical modeling and work well when fault patterns are well understood, this approach struggles with complex and dynamic systems like BESS, which can introduce bias and limitation. Model-based fault diagnosis uses mathematical or physical model to predict normal battery behavior and detect deviations that indicate faults. This method provides a structured way to interpret faults and their causes, making it highly accurate when a reliable model is available. However, developing an accurate model is challenging due to the complexity and variability of BESS, making it difficult to generalize across different conditions and real-world applications. Unlike knowledge-based or model-based, data-driven fault diagnosis leverage AI algorithm to analyze sensor data and automatically detect or predict faults. By using AI-driven anomaly detection, this approach identifies hidden patterns that traditional method might miss. Various AI techniques have been implemented to improve fault diagnosis in BESS. The study indicates that machine learning techniques are increasingly used in battery energy storage system fault diagnosis, with 19 papers discussing this method. Principal component analysis was the most frequency site, appearing about 7 times, followed by MRVM, which was mentioned twice, while other methods appear only once. Meanwhile, deep learning techniques have also been widely adopted in 9 studies, with LSTMN being the most frequently mentioned, about 2 times, whereas other methods appeared only once. In practical application, AI plays a crucial role in various aspects of BESS fault diagnosis, including parameter estimation, fault classification, condition prediction, dimensionality reduction, model optimization, and deep learning application. For regression approach, like GPR used to predict state of charge and state of health based on operational battery data. And then utilize classification algorithm to identify and categorize different fault types based on sensor data. Implement time series prediction to analyze historical data trends and anticipate potential failures. Employs techniques such as PCA to efficiently process and extract key feature from large dataset. Bayesian optimization to fine-tune model parameters and enhance prediction accuracy. is Bayesian leverage of advanced deep learning models, including LSTM, LSTMN, and one-dimensional VDCN, NN, to analyze time series data and detect fault with high precision, and so on. Despite its advantages, AI-based fault diagnosis in BASE faces several challenges, including nonlinear pattern complexity, as battery operation data is difficult to model accurately, and then limited data set availability, since real-world battery fault data is often scarce. Then influence of external factors such as temperature, battery aging, and workload variations affecting AI model accuracy. Sensor data, noise, and errors, which can lead to incorrect fault prediction. And the last, generalization issues, where AI models trained on specific data set may fail to recognize new fault scenarios. To overcome these challenges, future research might focus on enhancing, sorry. For to overcome these challenges, future research should focus on first, enhancing battery parameter estimation using advanced regression method like lasso regression or ridge regression, and then utilizing advanced classification models such as SGBoost, LightGBM, or JetBoost for improved fault diagnosis, and then improving fault forecasting through predictive model like ARIMA, SARIMA, or SGRU, and then applying advanced dimensionality reduction using TSNA or UMAP, and then implementing deep learning, innovation, and so on. For this review, it can be concluded that artificial intelligence provides an accurate and real-time solution for base fault diagnosis. However, challenges for such as data limitation, model complexity, and generalization issues must be addressed. Therefore, future research should focus on developing AI models that are more effective, efficient, and accurate to enhance the reliability of battery energy storage system and support the transition to cleaner and more sustainability energy. The following are the reference used in this study. Thank you.
Jihan ma'am, please ask any questions you may have for her.
Okay. Thank you, Prof, for your well-delivered and organized work. Actually, I see a real effort put in this work. But I have two inquiries. The first one is, do you think, Prof, that including 28 studies are enough for conducting such review? What do you think?
Well, I think this is not enough. Maybe I have to addition more reference.
Yes, because this is a review. And you know that in review papers, we expect more than this number of papers for, we can say that, robust findings and results. The second query is there any related review studies to your work in the field, in the literature?
Excuse me?
Is there any related review studies to your work in the literature?
Oh, yeah.
Or you are,
yeah.
Huh. Have you got my
Uh,
question?
Would like to repeat once again.
Yes. See, I asked that if there any related review studies, any review
We-
studies that are related to your work in the literature?
Oh, do you mean my future research?
No, I mean that there are, if there are any review studies that conducted the same topic.
Yes, there is one before, but not focus on AI, just focus on
Okay, so
energy.
yes, have you included this in your paper? And
Yes,
I mean, you contextualize your topic based
yes,
on
I
the
have.
literature?
Yes, I have.
Okay, yes, that's good. Okay, great job.
Nidhi ma'am, do you have any questions for her?
Yes, good presentation and very well structured. So I have just one query. Is it your study only about one type of material or battery? As you mentioned, lithium ion.
Yes, lithium-ion batteries.
Yeah, only one type of material. So you have studied only one type of material.
Just for example, one of batteries.
But there are lots of materials. So have you studied about this?
About batteries?
Yeah, material of batteries, different kind of material of batteries.
Not yet.
You have mentioned only one lithium ion.
Because lithium-ion battery have any advantages and used widely in the industry. For example, industry electrical vehicles.
Okay. Okay, thank you.
Thank you.
Thank you, ma'am, for your presentation. Now, next, I would like to call upon Yaroslav Yurchishin, sir, to present their research on the modeling of living matter. What code does nature operate in?
Hello, everybody. Do you hear me?
Yes, sir.
Thanks for your perfect pronunciation of my surname, because it's sometimes really hard for another people. Here, let me share my short, I would say, brief presentation. So I will introduce our work on the modeling of living matter. What code does nature operate in? And we wonder what kind of world do we live in. We are not only once interested in this, and do you see the presentation, right?
Yes,
Just
sir, we can see it.
brief the presentation, right?
Yes, sir.
Yeah, thanks for correction, because I wonder if it is seen. We are not only ones who interested in this question, and we do not have an answer to this question, but we have certain thoughts on this regard. In our opinion, the world is arranged on the principles of modern computer, which stores, operates, and huge set of folders and files with implausible hierarchies. Such a model of the world is understandable and acceptable to us compared to the accepted model of the Big Bang. The Big Bang model is accepted by us as misunderstanding of reality. But all these are just only our thoughts and our perception of the surrounding reality, and we present them not as a result of our research and experiments, but as our reflection And that is why we do not accompany our report with illustrative materials or the results of specific research. So modeling is extremely important to the description of medical and physical processes, and understandable model can help to understand the properties of processes and hidden phenomena of nature. As technical specialists, we are constantly attracted by these questions, and we think that such questions are of interest to many scientists. At the same time, we believe that many technical developments in various fields can be used in modeling living beings and diagnosing their physical condition. We consider the binary code to be the basis of living matter. And just hold on a second. And for us, a living organism is a complex mechanism whose various manifestations are not easily to understand. However, modeling it by leveraging knowledge of other complex mechanisms can be helpful. We view living matter as a real complex technical system. Biological and technical processes share many fundamental similarities. For us, the computer is based on a binary coding and encoding. This forms the foundation of modern computing. Modern physics, on the other hand, is rooted in quantum mechanics. And what do they have in common? In our opinion, it is coding. And we do not have research results on the indicated questions. These are our thoughts, and we present this message as debatable for further communication. When considering the human body as a system, we observe that it functions similarly to a computer and contains all the necessary functional components. This concept has long been recognized and supported by numerous existing developments, and we accept this, but our discussion here concerns the type of coding used by nature. However, the focus of our discussion here is on a different type of coding. What code does nature operate in? We do not know for certain, but we have some thoughts that we believe may bring us closer to a definitive answer to this question. A vast body of research has been dedicated to the genetic code and the structure of the DNA helix. We are impressed by the scope of studies conducted in this field over many years, and we admire these scientific efforts. But below we highlight just 2 points that are particularly significant to us at this moment. Genes double when cells divide. The DNA molecule is a double helix. The world around us is fundamentally based on rotational motion. Our Earth revolves around the Sun. It is believed that electrons move around the nucleus. Circular motion is described using the transcendental number pi. And we understand the concept of length, and we understand the concept of area. The meaning of powers of area, such as area squared, or to the fourth power, or to the eighth power, it is not entirely clear. However, practical applications require an answer to this question, as these issues extend beyond the academic realm. In our opinion, the ratio of space is extremely important. For instance, in vacuum, sputtering the voltage ratio between the electrodes and the plasma is inversely proportional to the fourth power of their area ratio. This relationship is essential for ensuring that the sputtering process targets the material in the sputtering chamber rather than the walls of the vacuum chamber of the work table. Why is this important to us? We find this quite intriguing. It suggests a potential model for understanding the fundamental structure of matter, particularly the atom, which we conceptualize as process of particle sputtering from the nucleus, which we identify as electrons. These electrons carry energy, which we associate with the negative charge of the electron, while the nucleus receives positive charge equal to magnitude but opposite in sign. In a neutral atom, the charge of the nucleus and the total electron charge are equal but opposite in sign. Therefore, in our opinion, the numbers 2 and pi are part of code combination. What did we achieve by performing squaring and root extraction? We immersed ourselves in a set of areas which might serve as confirmation that nature operates within a code combining pi and 2, and we are situated within one of these many areas. From the perspective of computer technology, this reminds us how information is stored, placed, and retrieved in a computer system. A primary file is placed in a primary folder, which is then placed in higher level folder, and so on. This is how we interpret the process of exponentiation and root extraction. In this regard, the physical constraints of the world, those that we do not fully understand and tend to perceive as fundamental postulates, are actually pieces of information from nature that we do not yet fully comprehend at a certain level. We think that E is not an ideal base for natural logarithms because it does not provide an exact replacement of multiplication by addition, nor does it combine additive and multiplicative properties in a meaningful way. This combination is achieved through the use of the golden ratio, which allows multiplication to be precisely replaced by addition during logarithmic transformations. Continuing with the consideration of the number E, we will keep the previous observation in mind that further discussions, this approach naturally raises more questions than it provides answers, but we find this acceptable because we are eager to hear the opinions of others in the scientific community. As for genetic code, it can be briefly explained as follows. When cells divide, genes multiply, doubling in number while retaining the individuality. This is the basis of living matter. But the fact that humans have not degenerated over time can be attributed to the nature's use of a binary code. Living matter in all its forms repeats itself in a similar way. This is the fundamental law of life, and nature was enshrined this law in the principle of similarity. Every living entity repeats itself in its own likeness. And geometric similarity serves as the foundation for evolutionary processes and design of life forms. The equation of integrity, which establishes the unity of the whole and its parts, is based on multiplying number by itself, thus raising it to a power. Many physical laws can also be described as laws of squares. For example, the force of interaction between two objects is inversely proportional to the square of the distance between them. The elementary quadratic equation of integrity has the golden ratio as its solution, the trivial golden number. The equation is of integrity for a more complex system with two autonomous parts has a square within a square and is solved by the binary golden ratio. We mentioned this to emphasize that the complexity of the issue and to suggest that a solution is possible through the joint efforts of mathematicians, physicians, biological, scientific people, medical professionals, and experts from other fields.
Excuse me.
Yes.
This is a gentle
Uh,
reminder that you have crossed your 10 minutes. You have 2 more minutes for
okay.
the presentation. Yes, sir.
Okay, I will be briefly. Apparently, the golden ratio did not receive support from the authorities by physics, much like Einstein's rejection of quantum entanglement. However, in the case of Einstein's views, we find ourselves in agreement with him because we consider it a type of correction between objects in nature that we have yet to discover, meaning it is our own confusion. However, we are not discussing physics, but rather modeling. And if a clear and acceptable model is created, even a programmer with average qualifications can write a necessary program. A successful model can help us comprehend the streamingly incomprehensible. For instance, a toy car is also a model, and a well-designed toy car can inspire an automotive designer to come up with innovative solutions that were previously unimagined. So as a conclusion, we can draw the following conclusions. We consider the binary code to be the basis of the living matter. We believe that the foundation of the emergence and preservation of identity lies in binary code, while encoding based on pi, e, and the golden ratio represents the manifestation of the existence and development of nature. Then the following biological and technical processes have common manifestations, and it's advisable to conduct the necessary research with the involvement of multidisciplinary experts from various fields of knowledge. Thank you for your attention. That's all from my side.
Jihan ma'am, please ask any questions you may have for him.
Actually, I don't have any questions. Thank you.
Thank you
Dr.
too.
Ravi, do you have any questions for sir? Okay, so all the presentations have hence concluded. I sincerely thank our authors for their excellent presentations and contribution in this session, and all our participants for being a part of this international conference. I hope this session was informative enough. We, on behalf of the whole team, thank you for the support during this 10th version and all the previous 9 versions of the conference. We will be happy to have you in the 11th version in 2026. All the presenters would be getting their digital certificates through email within 2 working days. Further, all the papers have already forwarded to the printer. The publication will be live within 6 months. Kindly cooperate with the team of ICICT 2025. I would also like to thank our session chair, Professor Jihan Mohammad Ahmed Al-Jaradi, for chairing this session. I'm extending a token of appreciation on behalf of Team ICICT 2025 and Global Knowledge Research Foundation and partners. Ma'am, I will request you to share any closing remark you may have for the presenters here.
Okay, thank you very much. Actually, we have an exciting lineup of speakers who have presented their research findings and delivered informative and valuable insights. And we cannot ignore this. Thank you again for all the organizers of this interesting and significant conference. Thank you for the moderator, Ms. Badil, and all the speakers.
Yes, ma'am. Thank you so much, ma'am.
You are most welcome.
And I would also like to thank Dr. Nidhi Tiwari for chairing this session. I'm sharing a token of gratitude for your valuable presence, ma'am. And please share any closing remark you may have for us.
Thank you so much. And I want to take a moment to express my sincere appreciation to all our speakers for their excellent presentations and valuable contributions. And a special thank you to our attendees for your active participation. I would also like to acknowledge the organizers and technical team, Harsh sir, Dimai ma'am, for smooth conduction of the session. I hope the ideas shared today inspire further discussions and collaborations. Thank you once again.
Thank you, ma'am. Now, before we conclude this session, I kindly request you all to please turn on your camera for a quick snapshot of the virtual conference. All right, thank you everyone. Have a good day ahead and take care.